Here in our science room, we have several members of the Lunar science team with us this morning. I'm going to pass the mic over to Dr. Gene Simmons, who is the chief scientist here at the Manned Spacecraft Center. And as we get breaks in the air-ground, Dr. Simmons will introduce his colleagues. And they'll also attempt to answer the questions of the newsmen here in the room.
Well, things seem to be going pretty slowly here. I'm Gene Simmons.
Roger, Dave. And Jim, the diverter valve is yours, whatever position you'd like. And did something else come out with the ETV? The wrapping on the package for the LEC. Roger.
We do have some people listening in as you can, remember, try to repeat questions and make it hard to call but whatever you can do. For some other, I don't see any sense using this hand mic because it takes too much time in between your calls.
We plan to try something a little different in this particular press briefing or conference. Namely, those of us up here plan to have a running commentary. As soon as there's something to comment on. In the hopes, and we're going to be rather... We're going to be rather wide-ranging in that some of the things we talk about will really be explanations of things that we see in connection with this particular mission. For example, we may talk about the formation of craters, which could take us 15 or 20 minutes total time, but meshed in between activities here, it may take somewhat longer. But we'll also try to answer all of the questions that you people have. Do you have trouble following conversation where it's meshed in with the air to ground? Is this technique all right? Okay. Well, for the record, let me introduce the people here with me. We will have two others later on.
Yeah. Commander has the red. It's like football.
There you go.
There you go.
And Jim, I'm going to put a big circle around this glass ball so we...
Yeah, did you notice his feet? Scott's feet were already covered with dust. They noticed a glass sphere last night from the window.
Well, very quickly, the people here with me, on my left, the chap who forgot to shave this morning is Stan Zisk. He's a physicist at MIT's Lincoln Lab. He specifically works on radar images of the moon with a facility known as Haystack. Next is Robin Brett, MSc, Chief of the Geochemistry branch. And I'm sure all of you know Professor Harold Urey from the University of California at La Jolla. Well, as I said, we'll have running comments and we'll entertain questions as you people wish to ask them. I will try to repeat the questions in order that we get them on the tape. We're taping this and it'll later be transcribed, not in real time, however.
Jim, we got that, and did they get your UV visor down?
I'll pick above the horizon there.
Of what?
The little spot above the horizon that I gave you the back.
What are they doing?
For the next time around, in addition to the Velcro and the Mesa blankets, we have all the tape. Really makes it tough. Any tape, I guess we ought to learn how to do it all with tape.
Beach. Oh, I think that's an artifact. If you look at the horizon, you can see how sharp it is. Very likely, if it were a planet or anything in the sky, it would be equally sharp. That would be my guess. With lots of clowns around.
I'm sure all of you know that the fellow doing the communications from Earth is Joe Allen, one of the astronauts. In fact, he was the chief coordinator for this particular crew.
That's also like Sun Valley, Jim. Yeah, powder. And don't move back, I got the tripod over here, okay?
Somebody ought to give RCA.
That makes for easy train digging.
What? Read that first time I just wanted to shower you.
The thing is that you want to give Dave Scott some credit for that, even though he may not have intended to. The fact that the spacecraft's orientation is just right, so that it's facing out toward the sun, but really into the shadow, is what's giving those beautiful pictures.
You can get complete credit for see how that LCRU works. This is only worth
Whatever you do, watch out for the sun, gentlemen.
about 24 minutes. This camera will be on. Then it goes off. You put it on the Rover. Of course, on the different traverses, you get 99 minutes.
Yeah, that doesn't move.
The crater here that I'm standing by, Joe, it's about a meter in diameter. And then there's a smaller crater right in the center of it, and that one has fragments around it that have
It's a beautiful picture.
exposed on them.
That sun really.
Where the larger crater does not have any glass exposed. It's a smaller crater within the large one. Roger, Jim, copy. And careful with the sun, Dave.
Thank you.
You want any coffee, man? Great. Thank you. How you like it?
Cream and sugar.
Cream and sugar? Black sugar, right? Black and sugar? Right. Cream and sugar. 3 cream and sugar, 1 black and sugar.
No, this is the man.
Discretion here might put it over about 10:30 or 11. Roger, Dave, that sounds good.
What is that?
make sure that we're okay on what you see, okay? Dave, we read all of that. We're getting a beautiful picture now. We're going to try to wind up with a tripod in the shade if that's possible, looking back
Look
towards
at the
the wind.
footprints. They're deeper than any of the...
Yeah, that's possible. We'll do that.
You probably know this from previous missions, but I'll just go over again the origin of glass. And when you see it as spatters on the rocks, this means that there's been impact, usually somewhere in the vicinity, and some of the material which the crater has excavated has melted, has been thrown up into the lunar atmosphere such as it is, and then comes down onto the ground, solidifies as glass, just as spatters. The spherules, on the other hand, the glass spheres, they solidify while they're still in transit, and of course they try and assume the lowest surface area, that being a sphere, and so you finish up with spheres, just like water droplets.
But unless I'm mistaken, one of the things that they first looked at here was a large glass sphere.
That's right, yeah, apparently.
So how would your explanation fit that?
Apparently a large chunk of molten material. So far we've got them up to about 3/8 of an inch.
Yeah, but I gather he's talking about grapefruit size.
I'd like to see it to make sure it's glass through and through.
You mean from the outside?
Okay, I'll give you about 10 more seconds. Roger, Dave. Very slightly more to the right so we can watch the rover come down.
Far after you get one, decrease past what's important, significant
Looks good. Looks good.
In that order?
You want to leave those settings at F8 instead of F11.
Well, you see, glass is a rarity on Earth.
It's okay,
There's
Dave.
very little geological glass. The average American takes glass for granted because you're surrounded by it, but it's all manufactured glass.
Watch that TV cable, man. That's really...
Obsidian is one of the names. Pumice is also glass, primarily. Glass on Earth occurs in association with volcanoes, and yet glass on the moon is extremely common and occurs, we think, primarily as a result of the many impacts that form the surface.
Another thing, glass on Earth, it's very rare to find terrestrial glass.
Sorry, what was the question?
Just ask me if that's your ladder.
No, he's pulling out the rover.
Big square package.
That booklet that I wrote has a sequence in it showing how the rover is pulled out.
I might remark in connection with the glass that there are two samples of glass on the Earth, the Libyan desert glass and the Tasmanian glass. I've suggested that they're probably due to comet head collisions with the Earth. I think one of the reasons we do not see much glass on the Earth is because we have a weathering phenomena of water that destroys it within a short period of time, and we don't see much of it. But the Libyan desert glass has been preserved for quite a long time and has exactly the composition of the sand on which it lies, so it must have been melted superficially right there, I think by a similar process.
Yeah, I've stopped in mid-sentence when he was saying something. It's very rare to find glass on Earth older than a few tens of millions of years. And here on the moon, of course, it's perfectly possible to find glass billions of years old. And as Dr. Urey said, the reason being that you've got water and other volatiles on Earth which will devitrify the glass, whereas on the moon, being poor in volatiles, the glass just stays there and doesn't devitrify.
Okay. Are you ready? Get the right thing up. Okay.
Some of the glass in the samples we've already examined is older than 3 billion years, and yet on Earth there is no glass in the geological record that's older than about 200 million years. So it's a factor of 10 older on the moon.
There are 2 published locations of Precambrian glass, Gene. Yeah. But it may be incorrect. One around Montreal.
The rover's going to come down into
The whole stratigraphy and so on may be
I think we'll be okay.
Oh, yes.
I want to get the camera too, Dave. Yeah, so, yeah, taking this off. I just started, it takes a while to unwind. Talking on all these slopes make it sort of sporty, doesn't it?
Some of these lunar glass spherules, if you get them under an electron microscope, look almost like mini moons themselves, because you see that they're zapped by tiny little micrometeorites and possibly lunar material accelerated by impact. And so they're quite extensively cratered, some of these things. They look nice and shiny and smooth if you look at them under a microscope, but under an electron microscope, very much cratered.
There's additional glass that's formed by impact and remains within the rocks, these micro craters that seem to be lined with glass, and then presumably subsequently the rock will be fractured on a larger scale and scatter the glass that was made. Yes, the moon. No, I don't, I find it difficult to understand, and perhaps my fellow panelists can explain. Oh, is that right? Does that apply to Earth too? How do you get impact formation of glass on Earth with the atmosphere in the way? Oh, well.
You get glass quite extensively around terrestrial impact craters. All you do is melt them.
Hey, you guys don't talk to yourselves. Talk to the microphone here in the audience.
Okay, why don't you hang on to that?
What happened?
No, we all know. In other words, the whole thing works.
I see.
Yeah, well, one half works.
By the time those of you who stay through this whole business have finished, you'll probably learn more about things like glass and other phenomena than you wish to know.
Well, I think this is a group effort, and if you guys feel we are staying too long on some particular subject, tell us and we'll move on.
All you have to do is ask a question.
You don't even have to ask the question. Just say stop, and I'm sure somebody will think of something else to say.
Poetic reading from Robert Frost halfway through.
Is that understood?
It's in the timeline.
She's coming down okay? Can you pull it out a little bit, Jim? About. Yeah, that's good. Okay, that's good. Outrigger cable, so I don't want over there, so that's it. Okay, outrigger cables are loose.
The present TV camera on the moon looks outwardly just like the one flown on the last mission, but the insides of it's greatly different, which is the reason you get a better picture.
Hey, watch the glass ball. Right, I got it.
Dr. Simmons, on the TV pass yesterday morning over the moon, it looked on the color set as if there were browns, and maybe there were greens, and other colors that we never hear anybody say are on the moon. What was that?
The question is, on the TV pass yesterday, there were apparently browns and greens and other colors, and what caused this? That's one of those easy ones for me to answer. I don't know.
I think we've had that previous one. The color pass one.
There seems to be
But that was not the real color.
there seems to be almost no color on the moon.
Well, or I guess Robin's going to answer it. No color or any color. Why don't you go ahead and say it?
All I was going to say is that the moon appears to be the colors really shades of gray with some brown. One of the minerals, pyroxene, is largely brown in color, but we're mainly doing with pyroxene, P-Y-R-O-X-E-N-E. It's a very common mineral in lunar rocks. But you're mainly dealing with shades of gray, and so therefore any setting of the TV away from that gray will give you apparent greens and even reds at times and so on. But we're still fundamentally dealing with a black-white situation with intermediate. The uniformity of the gray is quite interesting because when you look at the soil under the microscope, you'll see colors from reds to greens to brown to white to black. Quite a range, but all of these put together come up with this uniform gray.
Hey, Jim, I need you to get this hinge pin over here, okay? Hey, let me get this. Oh, see my hinge pin on my side? Well, it looks like it's almost all the way in. Yeah, but not quite. How about putting the tip of the tool on it, pushing it?
Incidentally, most of the
Yeah, let's line this up a little straighter. Let's pull the rear end back towards me. Okay? There.
What's that way up? Let's see it, the moon way around. 400 on the moon.
Hey, Jim, see if they're good on my side? Okay.
6. 7 small times.
About 7.
If I could get that.
Probably close to 8.
I'll scoop it wide, so. Okay, let's, yeah, hold on a minute there. I'm not sure the tool's going to be run or disconnected. Let's pick it up and move it back and turn it around, okay? Okay, turn it what, your way? Your way. Okay.
I think that's the EVA one. Looks like I'll check that, but it looks like we're about 43 minutes into this since
Maybe
it's
you
on
can
out.
pull it a little bit, huh?
So that should run up to 7 hours.
The rods.
The second one is the time left, the first one is the time left on the UVA. First one is time left on the UVA.
See what I mean?
Time left on the cliff.
That's not a good guidance. You have an overage there.
I see.
The way I read it, we're 43 minutes and 47 seconds in the EVA one.
EVA one starting from the time of depressurization.
Let me twist it this
Do you have a timeline here?
EVA-1 is 7 hours right in the nose of getting the flight plan.
I was wondering how much time had been allotted to get
Actually,
Rover
I've got
out.
that in my stuff.
I've got it here, Jack. There's about an hour and 25 minutes before they actually start traversing, so getting the rover going in time.
They've already taken the contingency sample.
Yes, the contingency sample at this time has already been collected and stowed back on the limb.
That was
Remember we had the pulley there? That was one of the contingencies.
It's always difficult to decide where a given idea comes from. In a program where there are so many individuals that have inputs and committees decide things and argue back and forth, but I think I'm correct in remembering that the idea of the contingency sample came originally from Jack Schmidt quite a few years ago.
Dave and Jim, pull the rover as far out as you can away from the limb, and then pull on the front end if you could. And by that, we mean lift up on the front end.
Yeah, lift up on the front end. Yeah. We copy, Joe. Get this stuff here. Try to listen to
I've never seen the rover taken out in exercises. I would guess it's probably going nominally at the moment. You know how these things are. Sometimes some little something will bind for a while, and then all of a sudden everything just goes smoothly.
as far as we can, and back as far as we can. Okay, I'm ready.
In fact, it looks like it's almost out to me.
Yeah. If you want to hold it there, I'll get in front of it. Okay, try and lift it up. Okay, I'll hold it. Yeah, I'll clear this.
You'll notice a change here compared to previous first EVAs. In the past, they've taken a contingency sample and then immediately put up the LSAP. And this time, of course, they go up and do a geological traverse and then put up the LSAP. The reason for that is that in previous landing sites, the rocks, the most important rocks to collect, were right at the site. At this site, you've got to go to the front to get those rocks. And so therefore in the past, by picking up the contingency sample, at least the most important rocks had been sampled, and so you could go into the LSAP. In this case, I think you can understand the reason for the change.
See if I get a downhill run here. Yeah, back up a little bit.
While we're waiting, could you talk a little
Back up a
about
little bit.
the best thing
Oh, go in reverse,
and
yeah.
how this expedition and what the return
That's good right there. Okay.
I've been talking a lot. I'll defer that to some others.
I'm sure that as the day unfolds, we'll spend a lot of time on the origin of the moon. Harold Urey is one of the people who have spent a lot of time thinking seriously about the origin of the moon. Certainly Robin has also.
One of the things that you note that as a result of the Apollo flights is that no one has changed his mind in regard to the origin of the moon.
Not even Tommy Gold?
Well, I don't think so. I'm quite sure Ringwood hasn't. I'm quite sure that Wise hasn't. And I rather think John O'Keefe keeps the same ideas. And I keep my ideas at least open. I'm not going to throw them into the trash can as yet. So it's very difficult to say how Apollo proves the origin of the moon. I have some specific tests that I'd like to see made that might be helpful, and I keep watching for them. If we found some xenon 136 or xenon 134 in excess in the gases from the moon, it would mean that the moon was a very old object like the meteorites, and probably older than the Earth. This would favor capture. Up to the present time, we have not found these. We've found slight suggestions, but they are not convincing at all. And so that test is is no good. Also, my ideas in regard to the origin of the moon will not be true, providing that volatiles have been lost throughout the entire moon. And at present, we just do not see any way to decide whether the volatiles have been lost throughout the moon. Many people assume this, but I would like to see some evidence in regard to it. So I'm looking for evidence and not trying to push a particular idea. I've had an idea that the moon was captured because I think it would be an exceedingly interesting object if that were the case, but that's very far from proving that that is the case. Well, I was discussing it with someone here on the base a short time ago, and I said, now when I got through describing what my idea was, I said, now I don't believe it, in the sense that I believe other scientific things, but it's only a proposal that needs to be investigated and to see whether it's true or not. I have my mind open about it. I do not think we have proof that my ideas in regard to the origin of the moon are certainly correct.
What are things? What are the time things that GM2 and GT?
Yes.
Things like hours and emission days.
What did he say? Is the dope?
But the important one to look at is the one that says TB5,
Yes.
which is the time elapsed on this EVA, 51 minutes and 53 seconds.
I see.
It's the only one you need to worry about. The one below that, first one, is the commander's life support system, how much time he has left in that before it runs out of oxygen.
Okay, Dave, and buckle up for safety here.
Oh, yeah. Okay, safety belt's on. Well, you set up a lot higher than in 1G, but that makes sense, doesn't it? Okay, air controller is locked. Brakes on, reverse is down. Circuit breakers, all except the aux and the nav are coming closed.
I don't see them. Do you see them?
The people are just out of the view of the TV camera.
Yes.
Erwin's on one side and Scott's on the other side, just out of view. Right, and Erwin is off, just off camera to the left.
Okay, switches are all closed. Okay, Houston, you ready to copy some numbers? No.
I think he said go, I think.
Okay.
Yeah.
Amp hours, 105 and 105.
In this great age of advances in technology, we have a few problems controlling our enclosed atmosphere in here. We shut out the air conditioning here for a few minutes. So we thought it was getting a little chilly, but it's just a go, no-go thing. It's either off or on, so give it a shout if it gets uncomfortable either direction, and we'll see what we can do.
Another one of the tests that I would like to see of Dr. Urey's capture theory is to get some accurate topography of the backside of the moon. As you all know, there's a tremendous asymmetry in terms of maria. All of the maria are on the front side, nothing on the back side. And I think it would be very interesting to see if that discrepancy is just because there was lava only on the front side, and if so, there should be some large unfilled basins on the back side. And I would guess that that would argue in favor of a capture theory, with the capture event being so much of a strain on the lunar material that it could have opened fissures into a still molten core and brought the molten material out to fill pre-existing basins.
I have thought, in connection with the capture theory, that possibly the moon was traveling around the sun and not rotating, keeping the same face to the sun, so that one face was hotter than the other. And that face got, by accident, turned toward the Earth, and hence flows from the interior were favored as a result of this. But again, this is a speculation for which it's very difficult to get any proof at all, and I haven't published it anywhere.
The lunar seas that formed during this period of
The filling of the lunar sea. But the interesting thing is to see whether there are lunar seas on the backside that have not been filled, or whether the bombs that form the basins themselves also are asymmetrical, because those two are basically different phenomena. First the bang and then the fill, and you wonder whether they both happen. You wouldn't see it. They drove off? Well, we can all go home. There they go.
Oh, for anything.
It reminds
Certainly
one.
one can say that the science is very interesting, but the engineering of the space program is absolutely fantastic.
Okay. Steering forward to bus, Charlie.
There was
Forward steering, Joe. Roger.
a year or two in Flagstaff. There was a rally of the proto
Forward steering circuit breaker, please.
rovers by the two prime contractors who were bidding for the rover, and it was possibly the strangest car rally ever seen, of these weird-looking machines going across the almost lunar Flagstaff terrain.
Some of these people may have been at that demonstration.
Some people have commented about the high price of the rover, but on the other hand, don't forget that if we didn't have the rover, it would require 2 Apollo missions to accomplish the traversing that's being done today and tomorrow, Monday.
Is the lack of front steering going to affect the use they make of the rover?
After all, in the car, we use only one set of wheels, front or back, for steering.
If I make a remark about this matter of Mario on the back of the moon, there are some rather big craters on the back of the moon, and they just don't seem to be filled up with smooth gray material. And if you transferred just one of the big ones from the front of the moon, say Imbrium, to the back side of the moon, and the two sides would look much the same. So the fact that the big craters are on the front may be just a matter of the statistics of small numbers. We expect to have them evenly divided, but by chance they wouldn't be in nature. And so it seems to me that one of the marked differences between the front and the back side is that there seems to be more of this smooth material that's flowed out of the interior of the moon and then on the back. And this would be indicated, say, by a difference in temperature. And a few hundred degrees would be quite adequate to account for the whole thing, you see. You notice I don't refer to lava. I refer to this smooth gray material. And the reason is because the seismologist will not come out and tell us flatly that there is some nice solid material down below. And without that, I just have a feeling that constantly talking about lava is not quite exact.
That's very interesting because the latest little look that I gave at some of the craters and some of the radar returns from those craters at the edges of Mare Imbrium show that some deep craters, as deep as a kilometer, one particularly, appears to have been made not in solid rock, but rather in some loosely compacted material, as if the layer of rock was not very thick, a thin layer lying on top of some pre-existing sort of regolith. So I wouldn't either be surprised.
Okay, fine.
To give the other side of it, I think there are many people who believe that there is volcanic rock at depth. I'm one of them. You can see
I'm sure I don't need to tell you to look at the landscape there in the background.
Do you have any idea what we're looking at? Your light might give you enough of a
Oh, look at the shadow. We're looking northeast now.
Oh, the question, I think, was what feature on a map
Yes, that's what
are we looking at?
Right, I was getting my own one. That looks like a smaller scale feature that probably wouldn't show on our photography.
What about the far?
Yeah,
the back one? I don't know. You can't.
We'll be able to. You remember?
We're looking
Direction, yeah.
almost due north, are we not? Or
Yeah,
northeast,
north
about
and
north
northeast.
45 east?
Yes.
Okay.
I know. It looks like
We copy Dave and Jim, and we're standing by for any information.
I think that you have a variety of opinions at this table as to how deep it was. I'm delighted to see it that deep because that's what the radar showed. Good. I'm sorry for the geologists, though, because they kept insisting that there were going to be lots of rocks there. And there may yet be once they get away from the limb, I hope. Lunch or just a cup of coffee?
There is certainly an obvious lack of material bigger than fist size in the viewing area.
This whole description of those domes and everything, nothing sharp is exactly.
That's right. Everything that we see there so far is completely rounded, which tells you there is some kind of weathering phenomena on the moon that is almost surely different from the weathering due to water that we're familiar with on Earth.
The most prominent object here is you can see that there's dust on the top of our cars, that they would pick up dust if they are not.
It appears that there is dust covering those little mounds or hills there.
Note the crater to the extreme left of the picture, halfway up or most of the way up that hill. It also has a rounded, smooth bottom, as if dust has been deposited even after the crater was made.
Remember all that discussion of the Karst-type process when those early ranger pictures? The idea being that there was a hole at the bottom, and stuff was draining out.
Mm.
You don't hear about this anymore. Running out.
No.